to work. Hello, I'm still Daniel Kahn, for everyone that wasn't in the talk from me, in the previous talk by me. I'm talking about splitting up monoliths today. I'm starting with my favorite monolith. I don't know who knows it. It's out of 2001 with the apes and so spoke Zarathustra. I could, yeah, the audio, I saved the audio here. So I am in the industry for almost 15 years, I would say, and my approach for this talk is I take some slightly personal approach, telling you what I saw in the past and what I did in the past with such monoliths, and also somehow, showing pragmatic approaches, how to approach new technologies. Speaking about new technologies, we can start with the next big thing that is there, and it's an architectural pattern in computer software, and it means that we split up applications and connect them through services. Sounds familiar, right? And this is completely new. And some might think I'm talking about microservices here. In fact, I'm talking about SOA in 2005. So it was already there. It was already there at this time, and I was also one of those who read those blog posts like, okay, service-oriented architecture, this is really the future. You really have to use it. Or this one, yeah, the future service-oriented architecture. And it looked great, basically. So we had all those whistle files. They were quite easily to understand, and this is an easy one because it's just a few mathematic methods like subtract, multiply. So this is the whistle file just to do this task. And so everyone started to become service-oriented. Everyone split up the applications in some way, and we all felt very, very safe because we were saying, oh, keep calm. It's still a mess, but we are service-oriented now, so we have no problem at all anymore. And I would say so that before we had unmaintainable, tightly coupled mess, and after that we had distributed, unmaintainable, tightly coupled mess. And while I'm just looking for my clicker for some, because this would help me now, but never mind. And it didn't took long until we saw this, and this was 2009. And the former future service-oriented architecture was declared dead. Those are 4 to 5 years. And what we could learn from this is, maybe don't believe the hype so much. Always, when a new technology, a new idea is coming up, everyone jumps at it, and many vendors jump into it, and then standards are declared, and everything gets very complicated. The good intentions that were there before are somehow gone, and at some point it dies out then. And still, service-oriented architectures were there to solve a problem. And I still think that we still need services for some reasons. And I've tried to find out the few main reasons we could use service-oriented architectures, or let's say services. The first one would be productivity, maybe. So if you walk into this room and someone says, yeah, you have to fulfill some tasks here, find something in those packets here, find yourself comfortable, then you might be a little bit lost, and maybe it would be better to see something like that. something that is kind of ordered, something where you get one of those packets and say, okay, this is now your packet, please deal with it, and this everything you do in there is completely your business. Technology choice, maybe. So what we've learned in the past is this we know is a good idea, so this will work. This is not so good idea, and this will not work, obvious now. But I really like this saying that says, if all you have is a hammer, every problem looks like a nail. So by deploying services and thinking in services, you could have the benefit to use the right tool for the job and not stick to one technology and do everything with that. And I think that's one very, very important thing about services. Another thing is scalability. So there are those things for everyone that was in Australia once. Those are those road trains, and they are great if you are in Australia in the outback and you have to drive 300 kilometers or 900 in one direction, and it's perfect. For most other purposes, we would maybe prefer something like this. So small things that can go everywhere, and if you really, really need to go somewhere really, really remote, you maybe would go for something like this. So, and this is something, talking metaphorically, this something resembles this whole service idea, I would say. Now we have monolith out there. Everyone who has legacy software to somehow to maintain, to support. Yeah. And do you like it?
When it does the job.
Yeah, as long as it does the job, right. So I have always, and this comes back to what I was talking before, I have always the approach, please keep it simple, please keep it pragmatic. Try to solve the problem and don't create a new one here. There is a guy who worked at a big company called Walmart, and he had this approach. So this is Aaron Hammer. He created the Happy framework for Node.js. Basically, he's a very, very smart guy, works now for Nearform, and he did the whole migration process of Walmart through Node.js. And as we might know, Walmart is a big company, an old company, and a company with much legacy software in there. And what he basically did was he created a front end done in Node.js that acted as migration platform. So it connected to all those legacy services behind and collected those data and presented it to all those new technologies in front. And he even used it for analytics, because when everything that passes through a system goes through this layer, it makes sense to collect analytics there. It was always also a performance thing, because in this case Node.js is just faster for answering requests than maybe compared to a big, huge GBOS thing sitting there and answering requests. And I will show you later why. Productivity maybe. Going to something small and easy to try and implement new things might help to be more productive, because you don't have to deal with all this legacy. Yeah, and this front-back commonality is something that might help you if you are dealing with Node.js, basically. So he says back-end and front-end programmers finally could talk with each other because they had the same language. They both used JavaScript, and this made it somehow easier to reason about code. And Walmart wasn't even the only one doing this. There's also this guy This is Jeff Harrell of PayPal. And he was a UI designer. So PayPal wanted to change the UI and found out that their processes are so fast and quick there that it takes 6 weeks to change a single line of text on the website. So, and they were thinking, okay, and now we want to change the UI here. How long will this take? How long will this take to deploy everything in our infrastructure? And they said, no, this we won't do it this way. And they put Node in front of it and first just used it for prototyping and used Node to render templates, and then they put it back to the backend guys. They had something going on with some Rhino JavaScript, so it's a JavaScript compiler, and then basically compiled the templates there, but they at least could prototype the whole application there. And then they went even so far that they implemented parts of the whole system in Node completely. And sometime later, and this is now, Node PayPal is hiring around 2,000 software developers in the Node space around Austin, Texas, because they are migrating the whole infrastructure to Node. And this is huge, I would say. And if we look at this, we also see what they are doing. They still have Oracle in the backend, and they still have APIs in C++. They didn't throw them out. They didn't do it from scratch. But they use Node.js and NGINX as in-between middle tier to communicate with all those backends. So they put in something that made it easier for them to implement new functionality and connect to different services around. And I would say this is the common pattern how we see Node.js currently in the industry. In very many customers are using it this way. So Intuit, Salesforce, Autodesk, even Apple has something going on with Node.js. So there is very much going on, and everyone is using Node.js basically like this. And then there are those unicorns, maybe Uber. They are most of what they do is Node.js. So they are a startup and they really build everything from scratch with Node.js in this case. Who is using Node.js already? A few, yeah. It's not so big in Europe now, but it makes sense to look into it, because I think it will really be one of those next big things. I will show you why Node.js is so special, because we could think it's maybe the next Ruby on Rails. Everyone is talking about this, and next year it's already dead again. And what you see here is maybe the most important trait of Node.js. Node.js can offload work that is doing asynchronous I/O. This is everything that talks to the database, to the file system, everything that talks with different backends, APIs, doing HTTP. Node.js can offload this to a thread pool over the event loop, and then the main thread is again free to answer new requests. And if though this request comes back with data, the main thread is pinged, and then this callback function is called. So you get a very fluid, very asynchronous program flow out of that. And this means that a Node application generally consumes less threads than every other technology around. And for that, it doesn't consume so much hardware, and it's really a good thing to use it in API-like scenarios. So every time you have to connect to backends, maybe consume some API from somewhere and then present it to some other tiers, Node.js is really the right choice, and that's the reason why so many even legacy companies are using this. Does this make sense? Okay. So I will show you an example now. This was a site I did more or less around 2002, maybe. So the design is here already quite new, but everything behind that I did 2002. I did it with PHP. From the architectural standpoint, it looked more or less like that. So it, as we know it, a front end, some rendering, then we have some categories, we have items. One special thing here is they used our ERP system based on IBM and DB2, so quite mainframe, quite big. They had all those item informations in there. And we pulled in those data from the ERP system into our system and matched this with categories, because the problem if you use ERP systems is that usually they don't have any customer views in there, so they don't have the categories you will want to see on a website, for instance, because that's not the view business wants to have inside the ERP system. Then there was some shopping cart, a user management system, checkout and payments, stats and accounting, and then we had this MySQL database down there. And then the customer came up with, hey, we want to create a printed product catalog. And we said, well, let's see. And then they said, yeah, and we also want to create a new front end now. And we felt slightly uncomfortable already. And then he said, and we want to have an app, and this should somehow connect to the rest of the data we have now. And I was like opening the back end of the system, and I was like, do you notice when you look at an application and you just don't want to touch anything in there, because it was done in 2002. The way I programmed in 2002 is not the way I'm doing it now. PHP even wasn't that far. It was something like PHP 3 or so, and it was not object oriented. It was spaghetti code. It was terrible. When I did it, I thought it was great, but in retrospect, it was quite terrible. So what the usual programmer and me also would like to do is something like that. So I say, hey, I do everything from scratch. Let's meet back in 2.5 years. No problem, right? But the problem is, customers don't want to do this because they have to pay you lots of money in front. They don't see instant results. They don't know what you're doing, and they still have the old solution for 2.5 years. So, and it was even in a textbook. I found something like that. The translation follows. I've really scanned it out, so it exists only on paper for some reason. So we have here the achievable capabilities of a system, and here we have the effort it takes to achieve these capabilities. And we see on this left chart, for some time, it doesn't take too much effort to achieve new capabilities. But after that, it gets incredibly hard to do anything new in a system. That's the saturation curve of a software application. At some point, software reaches its lifetime, and then it's really hard to do anything new in there. Almost impossible if you look at this graph here. And here is the point where you switch to a new system. And as you see on the right side, you see the new system, and you see that the new system starts with lesser capabilities than the system before. I think that this should sound familiar. Every customer usually is disappointed when you create a new application, and in the old application there was so much logic in there. implicit logic, things you fixed. And then he said, okay, now I have the new application. I'm beginning to fix problems we had with the old again, or we have to reinvent things again, because when it was in there in the old one, it has somehow to be in there in the new one, they think. And this is our problem. This is the delta, basically, between the capabilities of the old system that is gone and the new system you just did. And I would say the goal should be to narrow down this delta as much as possible, to deliver a new application in a short period of time and deliver it with almost the same feature set the old one has, plus the features you are adding right now. And this is what we did. So this was the old application. And yeah, I had this PHP developer who was good with some CMS system, and he was telling, okay, I can do the front end. So I said, great, you do the front end. And what I will do is I create a legacy connector on this old system. And this old system basically, so come up. This old system basically exported much of the functionality of this legacy connector exported much functionality of the old system simply via SOAP. So I created some kind of catch-all, export every function SOAP thing in PHP that's possible. Didn't care much about beauty, just to somehow expose the functionality to the outside. And then I created a Node API, some kind of, let's say, a prettifier that consumed this SOAP and exported it to JSON. And the new front end just consumed this JSON and presented it on the website, and also the whole actions, if something was clicked or entered in the basket, was more or less exported via the SOAP to the old system again. So this isn't very performant, but we had the same feature set in this migration period as we had before, basically. And the new developer, I would have felt ashamed to show him my old system, and I didn't have to, because I just created this connector, gave him the data he wanted, and said, okay, go ahead and create your application there. And this is what we came up after some time. Yeah, this shop, basically, they sell carpets and yeah, such stuff. This is what we came up. So we really had an application then, a front end that worked properly, and we had most of the functionality again. The old system had also, but we were not done yet, because, as I said, we also wanted to create some kind of new product management system, because the customer wanted to create this catalog, and we thought it might be a good idea to offload this whole product management system in its own application and not building it again into this new front-end application, because then we would have created the same monolith again, and now it was 2014, and now we are much smarter, and we now do it right. So we basically did it like this, and the result was then that. So it was built with XJS, some PHP in the backend. If you compare it with what I've shown you before, it's really slick. It looks desktop-like, and the product managers in this company really use it day to day to maintain the whole product structure. It even goes so far that this system now rules over the ERP system. This means that only those base data, like item numbers, they need to maintain the product, the item library are on the DB2 system, and everything else is on this web-based system right now. And they are really maintaining everything there, because if someone has seen these IBM screens, those black with the green letters, so it's not that easy to maintain product information these days with that, or put in some HTML somewhere in there. So it really saved them much of money and much of time to do it right here. So we now had this unified way to maintain items. And this is what we basically ended up with. So we had now a front-end system, a back-end system, a catalog, a user management, and everything was interconnected with this Node.js API, and we were able, the Node.js API just looked the same, but in the end we removed the whole legacy system, shut it down, and everything ran on the new system. So this took, I would say, also 2.5 to 3 years, but the website was done in a few months. So this is a big difference. And if you having to run your own project business, this means you get your money in faster also, and that's also quite important sometimes. And to show you that I'm not making this up, this is the product catalog. So what they are doing right now with that is that they have these price lists. And they send the price list to all their sellers every year. And before, there was one employee sitting half a year hacking that from Excel into Quark Express to create this catalog. And now they do it with one click. They are out and they can create it. It spits out a PDF. And she retired. That was also a reason why they said they need a new solution, because they said, when she's gone, no one knows how this works. Yeah, so as you see, we had really the result and that the customer wanted. I think the app is still pending, but as we have an API now, this node-based API, it's quite easy to create an app out of this, because consuming data and pushing it back to JSON is no problem. And Node.js basically really offers you much libraries and modules to create such APIs. With the Express framework alone, you really have to try hard to not build some REST application with it. So I've talked about Node.js before, and now just short introduction why to use NGINX now. And because also this is the scalability track, some context about that. So you have the consumer and you have the API here. And it's fine. So there's some website that talks with the API and everything's good. But what if you just want to offload, scale out those APIs to a multitude of servers? So, and you don't want to build the logic to decide with which backend the consumer should talk. You want to offload this, don't want to offload this to the consumer, but build something more generic here. This is where NGINX comes into play. Who uses NGINX already? Okay. So NGINX, first of all, it works a little bit like Node.js when it comes to how it handles threads. So it's also a very evented model it has, so it's also more performant than Apache, for instance. And it has the capability to very easily create reverse proxies and caching capabilities here. So what you can do now, you distribute your application maybe to the API to 4 different servers, and then define those as backends. And this means the consumer doesn't have to care. The consumer always talks with this NGINX backend, and then NGINX, you can choose round robin, whatever, distributes the requests to the different backends. This also means, for sure, that your REST APIs have to be stateless, but they should be anyway. So this usually works quite well. What you can also do, if you know that your data doesn't change that frequently, you can also very easily implement the caching into NGINX. And then you also have caching, and this will really help your performance quite well. So we used NGINX just to modernize our own company blog, and this really, I think, 70% performance gain through caching within NGINX. And I think that's quite a success here. Does this make sense? Everyone's awake still? Great. Just if you're using services and you're distributing it to many servers, so you're scaling out, at some point it might be that you have a problem in your system and you just don't know where it happens because everything is distributed and you don't know what is going on here. And this is just a little pitch of as placeholder for all those tools available. There are tools out there, they are called application performance monitoring systems that basically help you seeing all the tiers of your system. And when there is a problem, they will show you where the problem really happens. Right? So if in the backend or some third party you're calling is slow or down, and you get the call saying the website doesn't work anymore, you can look in there and say, it's not really the website. Basically, it's Amazon S3 that is down. So yeah, I know what to do. And this really helps in such distributed environments. That's a different approach. This product is called Ruxit. It also, this is a quite complex application, as you see. And you really see then which services are communicating with each other, and what is really going on in your system. And if there is a problem, it will pop up and will say you, MySQL is down, basically. That's the reason the website doesn't work. So all there is to say for the end of the conference is thank you. And are there any questions?
I have a question. What if you have, let's say, some really big database, and you would like to have multiple microservices on top of that? If you want to get rid of the legacy code, but the database should change.
That's a good point. In the end, you might want to gradually migrate the database after all that at some point. Now that you have all the service tiers on top of them, you can start to load off. This is basically what we did. We started to load off different things, like the catalog was then stored in MongoDB, for instance. So you have to gradually do this. And I think that's also a reason why MongoDB is so popular these days, because it's also distributed by default. So it's cluster another database. It's most of the time it's quite hard. It's relatively easy with MongoDB, and then you can scale out and let your services connect to it. But that's really is something.
It's okay that they are same data object between them. In some cases, it might be needed because you don't have joins anymore. It works most of the time, but MongoDB isn't a solution for everything. So there are cases where you want to stick with a relational database still. That's just an approach. If you want to scale out maybe with, let's say, MySQL, you can cluster it, but you're still sticking with the old schema. And as I said, one thing you can do is gradually move out parts of the application from the database and move it to other systems, and just do the same refactoring on the database side as you did before on the other tiers. But this, I would say, this would, maybe it should go hand in hand with the other thing you're doing. So if you build a new system part, you should load it off and try to how to migrate this data also. I would say so.
I have a question. This API, is it behind the firewall or is it open?
basically, you can. In this case, it is because it's really running within the company network, and only. And so this whole product catalog is only accessible through the catalog, through the company network, and it only exports a little API. So part of the API is exported to the website, so you can access just the functionality you need there from the website.
I was asking because how would you suggest doing authentication for the requests? Would the API to be not kind of viral?
Usually I take a quite, so what we do there is it's really IP based. So it's free for some IP range plus. Then you have this regular authentication for the API, and there we are using tokens. So I'm usually just creating some custom token that gets refreshed all the time, and I send it with that. Together with the IP constraint here, I think this is quite safe. And you should still not expose things from the. There should be no exposed API for things that no one should ever have accessed, and you really have to kind of close it off in different ways, or split the kind of API calls you are doing, like a public one and something that really maybe uses some kind of SAML authentication or something like this for the internet network, maybe so single sign-on things are usually used for inside things.
So the frontend that holds the state, is it also on Node?
It's PHP.
It's PHP.
Yeah.
Is it like normal, or is it just in your case? Is it like a normal approach to have a session in PHP or something similar?
Yeah, usually you're maintaining everything that is state on the front end. This means what I do usually when I'm doing regular Node.js applications, I'm creating a front-end application and give it a MongoDB instance or Redis, whatever, on its own. There I store the sessions and everything that is runtime data that is consumed all the time by the clients. I don't bother the backend with all those user data.
Yes, but this front-end, is it usually built in PHP or something similar and not in Node.js?
No, that's just was the case for us, because at the time we were doing this, there weren't too much frameworks for that around. It was just and some things are still better done in PHP, especially things that are CMS systems or maybe blogs. So there's still you can use Node.js for plenty of things, but PHP has a history of over 15 years, and there is so much software around that this is foolproof and used all around the world. So you should just stick with that to get the job done.
You mentioned that basically restricting the access to the API, you are using the IP restrictions as well as tokens and so on. You see that in case if there is a need to restrict the certain data within the same API based on the profile of the user, how would you implement this?
Usually, so what I would do is I would create, or what I'm doing is if I have a user, I assign this user a token. This is stored in the backend. And then this token, the front end consumes this token basically and uses this token to authenticate this request from this certain user for a certain amount of time over this API. That's the only way you can do it. It's the same for almost every, even if you use a database in front. You can, it's always some session you have to pass in there, and this authenticates basically the user, but it's still stateless in a way that the backend doesn't know the user sessions currently going on. It just has some, let's say, dictionary with users, and you waking up this session by passing in this token, I would say.
But if you have a scenario that certain user can access data fields 1 to 50 and another user can access basically everything,
record level security permissions in database or authorities that they can have access to?
That's basically not such a big problem. I have it for one application. I just ask the application to as the user logs in, single sign-on, whatever, and then there comes an object back with the things the user is allowed to do, and then I store this in a session on the front end, and the front end knows what the user is allowed to do. I'm securing this then on the front end, but also on the back end. So you can't say, okay, when I'm securing this, maybe just in the browser, just to be sure that he isn't allowed. You really have to secure every tier and act as if the tier in front doesn't know anything about security.
Yeah. Both some JSON, for example, directly that you need to protect.
Yeah, sure, absolutely. And I've seen myself leaking sensitive JSON data lots of times, finding out, oh my God, what you are giving away here directly from the database, user data, customer data. Maybe you have this special field where everyone can write private things about the customer, and when someone writes, oh, he's an idiot, then you export it with every time the user logs in, and it just has to look at the JSON. So this, yeah, you really have to take care of this.
I think there was a question maybe also for the record level security, not smart data, but what record you can see. So
yeah, but those are data structures basically stored somewhere in the backend where you have this record level security, and then when the user, you have a token, and when you do a request, you send in, I'm user XYZ, and I want to access this data set. Then the backend sees, okay, this is the user, these are the permissions, and this is the data I give back there. So that the logic stays quite the same. It's just the transport layer that changes in some way. And now I have to go off to my plane. Thank you.